Okay, so we are on page 13, okay? So last week we reviewed all the exponent law, including the negative exponent. Today we're gonna look at what happens if the fraction appears in the exponent, okay? It doesn't have to be fraction, it could be decimal, right? Because decimal, you could rewrite it as fractions, right? So for example, like the question here, 25 to the half. Sometimes the question they will write it like 25 to the 0.5. So you could rewrite it as 25 to the half first before you begin. Okay. So here our goal is try to figure out what if the exponent is a fraction or decimal. What do we do? How do we find the answer? Right. Same thing with this one, right? 2 to the 5 over 3. Okay, because we never have exponent as fraction before. So what we are going to do is, if you have a different color pen, okay, you can use it as well. So first I'll write it as, I'll copy the question again, 25 to the half, but the half, I'll write using the red. Okay, 25 to the half. And then the 25, I can rewrite it as 5 squared. Right? So the blue part is the blue part. And the exponent half is still there. Right? The left side is still the same as the right side. Make sense? Right? 25, I just rewrite it as 5 squared. So now you have one exponent on the inside, one exponent on the outside. Okay, what can we do with the two exponent now? Henry?
You can multiply them.
Okay, so we can multiply the 5 with the half. And what would that become then?
That would be 5.
Not 5.
It's 2.
Yeah, my bad. I don't know why I wrote 5. Okay, 2 times a half. What would that equal?
That would equal to 1.
Yes, okay. So equal to 5 to the 1, which is just 5. Okay, so your answer for 25 to the half, it becomes 5. Okay, so how can we make 25 become a 5? Another symbol that we learned before that can do the same thing is the square root. Okay, so we can sort of guess, if I put a square root on 25, it can also be 5. So therefore, square root has to do with a fraction exponent. Okay, so the 1 in the numerator, right? 1 over 2. In the exponent, the 1 in the numerator is like the 1 over here. And then the 2 in the denominator is on the outside because it's a square root. So this is called the index. Index number, the 2, okay? The little 2. So denominator goes on the outside. Okay? So this, when we put a square root, it also gives you the 5. Okay, so for example, right? Example, if next time you see 49 to the half, then you can rewrite it as square root. Okay, so rewrite it as 2, 49 to the 1, right? Which is 7. Okay, so that's for this one. You can draw a line across. Okay, so you can raise your hand if you got everything down so far. So exponent, okay, if it has a fraction, denominator goes outside. Okay, that's why you need to remember. Denominator, you see a 2, it gives you a square root. Okay, 2 goes on the outside. Okay, please raise your hand after you copy this down. And then we'll look at another example. Okay, so this is if the numerator is 1, right? Denominator is 2. Let's look at something else. If we have 125, okay, to the, okay, let's use something smaller, okay, easier to think about it, okay? We'll use 8. 8 to the 2/3, okay? Once again, I'll use a different color, 2/3. So 8, right? Just like 25. 25, I can write it as 5 squared. Can I write the 8 in a different way? Okay, using exponents. Okay, how do I write the 8 using exponent in a different way, using different numbers? Anyone?
Can I try?
Yeah, Tony?
Maybe 2 to the power of 3.
Yeah, very good. Okay, 2 to the 3. And we write it 8 as 2 to the 3. So the blue part is the blue part. Exponent is still on the outside, right? So now we do the same thing as before. The 2 exponent, they can multiply, right? So it will give you 2 to the 3 times 2/3. Okay, what is 3 times 2/3? Geoffrey? Geoffrey? Yep.
2.
2. Okay, so we can write it as 2 squared. Right? And 2 squared, of course, that equals to 4. Okay, so this gives you the answer here. Okay. Now, how do I use the radical, right? 2 squared is the 4. So if I also want to get to 4, okay? So using the experience we had before, right? The denominator is a 3. So that tells you on the outside, we should write a 3, right? So your root is not a square root anymore. It's called the cube root. Okay, so a little 3 out there. And then on the inside, you have 8 squared. Okay, denominator goes to the outside. Writing out like this, okay, you can write it like this, 8 squared on the inside, right? You can, okay, you don't need a bracket. Or, okay, we'll write or, okay, write it or. Or you can write it as 8 and then cube root. And then the whole thing square. The difference is the first one is you square the 8 first, okay? 8 square and then cube root. The second one is you cube root it and then square. Both ways should give you the same thing. Okay, so for example, I think we should give it more space, okay? I'll pull this to the side, right? So if it's the first way, right? First way, we square the inside, you get 64, right? And then you cube root that. Cube root of 64. So you think about one number times itself 3 times can give you 64. Okay, Aaron, what number times itself 3 times? Will be
4.
Yeah, very good. Okay, 4 times 4 times 4. So answer will be 4, right? So you see the answer also gives you 4. Now, if I do the square later, okay, I do the cube root first. Cube root of 8 is 2, right? I'll write a 2. And then I will square. This also give you 4. right? So either way, they both ends up the same answer, right? They all get 4. So just remember, the only rule you need to master today, right, is the denominator has to go outside, okay? And then with the 2 example we see underneath, the second way is better because it makes the numbers smaller first, right? If we cube root first, the 8 will become smaller and it will be easier to square. If you do the first way, you get 64. Sometimes the number is too big. It will be difficult to find the root, okay? Like cube root or fourth root, okay? So I would prefer to do the second way, right? Easier to root first. Okay, so that's how you deal with any fraction exponent. Right? Can you raise your hand after you copy all the things down here? Does anyone have questions about what's explained here? Any question not clear? Anything not clear? Okay, so for example, on the right side, right? So I would like you to try to rewrite this, okay, in 2 different ways. Okay, 2 to the 5/3. Please write it in 2 different ways. One is the exponent, one is the root first, the other way is the exponent first, right? So we can say, write it here, or, okay, 2 different ways. Okay, after you got the 2 different ways, please raise your hand. We'll check. Does anyone have questions about which 2 different ways I'm talking about? One way is without the brackets, okay? The other way is this one, okay, with the brackets. 1 and 2, okay? Just write it into the radical. All right, please raise your hand after you've done that. You don't need to evaluate, okay? Just practice, write it out using the radicals. So the common mistake is to put the wrong number on the outside, okay? So remember, denominator goes to the outside. Okay, please raise your hand if you are done. Okay, can I have Cat, can you write out one of them on the screen?
Okay. Mm. Okay.
Okay, thank you. Very good. Okay, so this one is you do the root first. Okay. Can I have Angeline? Can you write it on the screen the other way? Very good, very good. Okay. So this way, the second way is you put the 5 on the inside, right? So if you do it this way, you don't need a bracket. Okay. Right. So let me clear that. I'll rewrite it again. So it'll be cube root 2, and then the whole thing to the 5, or cube root of 2 to the 5 on the inside. Okay, 2 different ways. Right, so if you know how to change to the radical form, sometimes you can evaluate, right? So like the example I gave you, right? You could continue to get to the final answer. But because the 2, right, cube root of 2, we can't really get a nice number. So we just stop there, okay? For this one, for the second way we did here, we could do 2 to the 5, right? So you could write it as 2 to the 5 is 32, I think, right? So they're all the same. So these three expression, they all equal each other, right? So we just go as far as we can. If we can evaluate, then we do that. All right, so let's look at these 4 examples. Each of the 4 examples are different. Okay, some of them you can evaluate, some of them you can only write it as radical. Okay, and if you look at question C, it has a negative. You can think about what does negative do, right, from last week. Okay, and then question D, it has a variable, right, also has a negative half. So think about what it does. Okay, so just go as far as you can and then try to reach to an answer. Okay, and now we'll go over that to show you like how far we want you to go, right? When do you stop as your answer? So just give it a try. Don't worry about right or wrong. Okay, just go as far as you can. All right, so when you finish all the A, B, C, D, you can raise your hand. Okay, so let's take a look at some of your answers. Bernice, what do you have for A?
I just have 3 square root.
Okay, how about I just have you write it on the screen? Okay.
Okay.
Yeah. Okay. Thank you. And yeah, can you write down your final answer for B? And Naomi, you can write down answer for C. Okay, and Jenny, what's your answer look like for D? You can put it on the screen. Okay, 4/x, 1/9, 8, and square root 3. Okay, so let's go over these 4. Those of you haven't finished, do you have questions? Like Tony, do you have anything different from what you see?
Me?
Yeah,
Not really.
you got everything the same?
Didn't get the for the last two.
Last
C and
two.
D.
Okay. Anyone else want to add to the answer here? Okay, we'll look at the first one then. Okay, so again, the rule is very simple, right? You look at the denominator of the exponent is a 2, right? So you bring the 2 to the front, to the outside, right? So that means a square root, and then 3 to the 1, right? Of course, the 1 you can make it invisible, right? So you just write it as 3. If it's a square root, if 2 is outside, you don't have to show it. That's also invisible. Okay, so that one is correct. Very good. We'll look at the second one. Okay, denominator goes to the outside, right? So it's a square root. And then remember, I prefer to have the radical first, right? So I put a bracket to the cube. Okay, so we evaluate the inside. The 4 is okay to find a square root, right? So that gives you 2 to the cube. So I'll give you 8. Okay, so that's how you get an 8. 8 is correct again. Very good. Okay, and then this one, okay, we have a negative. Remember when the negative exponent we learned last time? Okay, what can the negative do to the questions? Mackenzie, what does negative exponent do?
They flip, don't they?
Are you Mackenzie? Okay. Hello, Mackenzie, are you there?
Hello.
Yeah. So if we have a negative exponent, what does it do to the number?
Nate. It flipped.
So what would it look like after flipping?
Um. It is 3/2.
Do you flip the exponent? Let's say if we have, let's say if it's 5 to the negative 3. How do you do the flipping?
Um.
Very ugly negative 3. I'll rewrite it. 5 to the -3. Okay, how do you do the flipping?
That is 1/5 to the power of 3.
Yeah, so you bring the whole thing to the bottom and then exponent become positive, right?
Yeah.
Okay, so we want to do the same thing for this one as well. 27 to the -2/3. How do we do the flipping?
So that will be 27 and
Remember, you need to bring the whole thing to the bottom,
oh, okay.
right? And make the exponent positive. How do you write it? You can show it on the screen, okay? After flipping, what does it look like? You can write it on the screen. Do you know how to write it on the screen, Mackenzie? Hello, Mackenzie, are you there? Can you keep your mic on? Do you know how to do the flipping? Are you writing or what are you doing? Hello? Oh, okay. No, I see. Yeah. So
like that.
3/27 square. Is that what you wrote?
Yeah.
Okay. If you look at the example, look at the question, okay? In the question I circle here, which part is the exponent? Which number is the exponent?
-2/3.
Yes, okay. So just like the -2/3 is like the -3 on the right side in the example here. The -2/3 is like the -3. When you do the flipping, you have to bring the whole thing, okay? The whole thing to the denominator. Not just part of it. Okay, let's ask Wilson. Do you want to try? Can you show me how to do the flipping
Sorry, for which one?
for this one? Question
For
C.
C?
Yeah.
It's just like 5 to the -3 power. It's just like 1/5 to the third power. You did it correctly.
Yeah, I did it correctly. I know. So how do you do it for question C? Do the same thing for question C. How do you do the flipping then?
Is it
You can write it on the screen, okay?
I'm not really sure, but is it this? No, 2/3, sorry. Hang on.
Yeah, very good. Okay. So you just copy the whole thing, the whole question, and then put it in the denominator. Okay, and the only difference is the exponent is gone. The negative is gone. Okay. Yeah, that 2/3 is kind of too big. It's okay. I'll write it. Can you help me clear? Yeah, thank you. You copy the whole thing again right? 27 to the 2/3. Instead of having a negative, I put positive. That's how you do the flipping. Okay, you have to grab the whole thing. So the common mistake is to flip the exponent. Okay, you never flip the exponent. You take the whole thing and bring it down. So now you just focus on the denominator. Okay, for the denominator, the exponent has a 3 at the bottom, right? So 3 goes out. So that gives you cube root. Okay, and then 27 squared. So we don't want to do the square first, right? Because if you do square first, 27 squared is more difficult, right? So we would do the cube root of 27 first. What is the cube root of 27? Geoffrey?
3.
Yep, okay. So we have 1/3 squared, and that gives you 1/9. Okay, so 1/9 correct. So remember this example, okay? This one, very common to flip the exponents, okay? Never flip the exponents. All right, last one. Okay, last one we have 4/x, and I remember I think I saw Cat add something in. Did you do something, Cat? What do you have? Oh, so you have an extra root. Okay, so 4/x. Anyone else has something different? Henry, what do you have?
I have one over the square root of 4x.
So like this. Is that what you have?
Yes.
Okay, so we have 3 options here. Anyone else want to add in your answers to check? Okay, Tony, which one do you have? Or you have something different?
No, I redid the question.
Oh, sorry, I think I got mine wrong. Yeah, it's the one 4 over square root of x.
Okay, how come? What's the difference?
Because the exponent's on the x, not on 4.
Okay, very good. Okay, so this one you can try to differentiate with this question. Okay, I'll make up another question. If you see a question like this, 4x in a bracket, and put a negative half on the outside. Okay, compare with the question that's given here. For the one that has bracket, the base is 4x. Okay, I underlined it. For the question that's given, the base is only x. Okay, so if the base only x, then only the x can be moved. Okay, so if you do the flipping, let me clear the drawing first. Okay, so if you, after you do the flipping, only the x part, okay, this part I circle, only this part will flip to the other side. Okay, so 4 has to stay, x to the half. Okay, if there's no bracket. If you have brackets, then everything in the bracket will need to flip. So that means you're left with 1 at the bottom, okay, 1 at the top, and 4x at the bottom to the half. Okay, try to compare these two. One has bracket, one doesn't have brackets. Okay, first one, second one, okay. So if it's the first one, then that will give you this answer. Okay, if it's the second one that has bracket, then this will be the answer. Very different. Okay, make sure you pay attention to the little details. Okay, whether it has bracket or not. Okay. So before we talk about the bottom box, okay, I want you to try a few exercise first. Okay, so you can turn to the next page. It says, please write it in radical form. So radical form is referring to this way. Okay, radical is the square root sign, okay, or this way. This is also the radical form. Okay, so you don't need to evaluate, okay? You don't need to continue find the answer. You just get to the radical form. So please complete the question 3, all the 8 questions, okay? And then you can raise your hand. Let me lower your hands. Especially pay attention to G and H, okay? G and H, one has bracket, one doesn't, okay? Think about what it means. You can look at the example we did before. Some question has negative, some questions are positive, okay? So think about how do you do the flipping. Right, so I will give you about 5 minutes. We'll start going over. I'll ask some of you to write your answer on the screen after 5 minutes. So Naomi, we are on question 3, example 3, okay? Yeah, we cover all of them. Okay, these questions you don't need to evaluate, okay? Some of them has variable, you cannot evaluate anyway, right? So just write it in radical form, that's all. Shouldn't take too long.
Jason, can I go to the washroom?
Sure. Okay, I'll give you an example, like 25 to the half, Okay, you just write it as square root 25 and then you stop there, okay? Do not write it equal to 5, okay? We don't want that. That's called evaluate, okay? This is evaluate. This is called radical form, okay? So leave it in radical form. Do not evaluate. If the exponent has negative, you need to flip it, okay? All right, one more minute. Okay, Angeline, which question are you on?
The last one.
Okay. All right, if you are done, please raise your hand. How about you, Aaron? Which one are you working on?
Oh, I just finished.
Okay. All right, so let's go over the answers. Okay, I'll just write the, okay. Henry, can you do question B?
Do I just say the answer or
Yeah,
do
write
I
down
like
the
it?
answer on the screen.
Okay.
Yeah. And Wilson, can you do C? And Valerie, can you do D? And Naomi for E. Mackenzie for F. Okay, and G and H, right? G and H very close. Jenny for G and Bernice for H.
That was the only one that I didn't get.
Okay, you can look at the last example we did. Okay, on the previous page, right? We have one question has bracket, one question doesn't have bracket, right? I think was for the 4x, right? 4x to the half or negative half, right? Think about, look at the notes there. It could help, right? If it has a bracket, that means the bracket, the whole thing is together. If it doesn't have bracket, right, then which part is the base? Give it a try, okay? Look at the example and think about what it should be, right? Yeah, doesn't matter if it's right or wrong, okay? Just at least you tried it. Okay, now we got everyone's answer. Let's go over each one, okay, one by one. So I'll use the red, okay? Let's start with B, okay, because it says radical form, right? Radical form. So do not do any evaluation. So looks like Henry did some evaluation, right? We have a 625. So if they say radical form in the homework, you just leave your answer in this way. Cube root 5 to the 4. That's all, okay? You don't need to find the answer for 5 to the 4. Okay, Henry?
Okay.
Yeah, okay. So unless they say evaluate, then you do more steps. Okay, question C. Right, first you have to flip it, right? So you grab the whole thing. Okay, let me erase the name. Grab the whole thing down. Right, and then the exponent goes to the outside, which is good, very good. 9 to the 3, okay? So that's correct. Okay, next one, question D. Okay, I'll write the answer on the side, okay? 4th root 9 to the 3. Okay, the next one is 5 over 2, right? This one, it doesn't have brackets, so the base is only 25. Okay? So on the 5 over 2 only affects the 25. So that makes the negative state has to stay on the outside and then square root, right? 25 to the 5. 5, you can put it on the inside or the outside, okay? Not in between. Make sure you are clear where you put it, okay? If you put it on the outside, then you better have a bracket, right? Or you can write it like this. Bracket 25. Now I know it's on the outside, okay? And then for Naomi's, right? You flip the whole thing down and then bring the exponent out, the denominator out. Okay, yeah, so that's correct. Very good. This one, same thing. Okay, yeah, this one you got it. And you had the bracket. Very good. Okay, 1 over k to 3 over 4, 1 over k 4th root cube. Okay, question G and H. Okay, it's best that you put a star there. Okay, these two are very similar. because you have a bracket for G, so the phi x need to be included together. Okay. So for G, so Jenny, you can take a look. Make sure you keep the brackets. Phi x needs to be together, and then cube root on the whole thing. Okay. Phi x on the inside. You can put a square here, or you can put a square on the outside. Doesn't matter, okay? But the only difference is you need to have phi x in the bracket. If you don't have the bracket, right, like you did over here, you have a square, then that square only affects on the x. Okay, so you don't want that. You want the exponent to affect the whole thing. So you need a bracket, okay? All right, last one. Last one is the x is the only exponent, okay? It doesn't have brackets. So the phi will just stay there. And the root, right? The exponent only affect that. So root is only on the x. And then square. Okay, you can put a square there, or if you like, you could put a bracket, put a square outside. Okay. So the wrong part is that you have the phi inside. So this and the answer that you got is actually the answer for G. Okay, Bernice.
Yeah, okay.
Right. Yeah. So if there's a bracket, everything is inside the radical. Since there's no bracket, the phi does not move at all. Right. Okay. So let's have a break. And we'll continue, okay, to practice more at 2:50, okay?